So hopefully you remember these. This one's called a parabola. This one, we don't have a name for it, so the teachers usually just call it a snake function. You're going to see that more later. Next up, the V-shaped function. This is the absolute value one. Remember, absolute values always come out positive. See how there's no negative answers down here? They all come out positive. To see absolute values, when you come out of an absolute value, has to be positive. Unless it's 0. Okay? What else? You need to know this one. It's a square root graph. You know, if you put in a 4, square root of 4 is 2. That's why this point right here is 4 comma 2. You put in a 4, and the y will equal 2. See? All right, so your best friend in graphing is this XY chart where you go, I'm going to put in some numbers that'll work nice, like square roots that work nice, like square root of 1. What is the square root of 1? It's 1. And that's why it goes through this point, 1 comma 1. Because you put in a 1 for x, you get the square root of 1, and the square root of 1 is 1. So you make points like this on an XY chart. That answers a ton of problems if you can just put in numbers on an XY chart. If I stick a 1 into this function, watch what happens. 1 over 1, y equals 1. 1, 1. All right, so knowing how to put numbers into a chart, really, really good. All right, going on to this one. Everybody look at these. These are the parent points. Do you get that if you put this into the function, you get this as the answer? Y equals that. Negative 2 to the third is negative 8. Or if I stick this in the function for the x, y equals absolute value of that, which is always comes out positive, so it's 1. So again, you can get these by sticking the numbers from the x column into the x, and then reading y equals whatever the answer is. 0 squared is 0, so that's why it's 0, 0. All right, so those XY charts are really important. If there's one thing we're going to use more than anything else today, though, it's high-vo. Horizontal on inside, vertical on outside. This is so important. But do you know which way horizontal is? Use your hand. I don't want to bias you in the classroom. Use your hand and show me what horizontal means. All right, yes, it's this way. Okay, so if you're going horizontally, you're going left or right. It's like this, right? And if you're going vertical, you're either going vertical leap or vertical down, which could be like a negative number. All right. Now, this is the same thing except they're telling you, what if it's just a negative? That's called a reflection. Let me show you what it would look like. Here's your parent graph. It looks like this. This is the square root graph. Square root of x. You remember that one? Looks like a little bit like a ramp or like a bike jump or something. Okay, what if I put a negative in it? Well, if I put it on the inside, it's going to go left, right. It's going to go this way. And it'll look like that. That wasn't perfect. I'm going to try again. It'll look like that. Okay? That's a left, right, or a horizontal. That would be like if this was square root of x, this red one would have been square root of negative x. Go ahead. Ah, I get your point. But if I put in like a 2, you're right, it won't work. So let me just show you what that means. In this equation, if I put in a positive 2, it won't work. See, here's a 2. Look, there's no graph here. But if I put in negatives, I'll have a negative of a negative. See what I mean? So if I put in like negative 4, then I got negative, negative 4, and it'll work. So it still doesn't destroy math. It still works. Math still kind of holds together. So you put in a negative 4, it works. And I get square root of 4, which was 2. Okay. Why would this be over the x-axis? If I draw what that looks like, this is the x-axis, this is the y-axis. Do you get its Still VO. REP, what does the VO stand for again? V stands for what? And O stands for what?
Vertical.
Yep. Vertical on the... What's the O? Outside. Vertical on outside. Okay, moving on. On this problem, I got some inside, I got some outside. Now I know you're all naturally wanting to save time because you don't want to spend all of your life doing math homework. In fact, if it was all of your life, that would be a pretty sad life if all you did is do math homework. Okay, so I get it. You're going to want to get your homework over quick. So here's some abbreviations. Take a wild guess what R stands for in the context of that. Right. R9. You can't just say R. You got to say how far R. Okay, so right 9, and then what do you think this would be the fastest way to say that? D7. What do you think the D stands for? Down 7. Does that make sense to you guys? Everybody do that for these 4 questions. Now I know there's some that are weirder. These negatives, we don't want to call them R for reflections, so we're going to call them F for flip. So that's a flip. This is also a flip. But what kind of a flip? Thankfully, there's no U because, you know, we don't want to say FU. But we could say UF, or there is no U, though. There's only V for vertical or H for horizontal. So VF would be vertical flip. And I know they're technically called reflections, but we're going to call them a flip. All right, so what kind of F is this? What kind of F is that? And then this is either right or left, and this is either up or down. Okay, label these, and then be ready to be called upon. I'll give you a minute to work. Just look at it, label them. Yes?
I was just wondering why, for the first one, you could say negative.
Because it's not a -9. It's just going to move it right 9. Because really, if you actually look at the graph, you won't be in the negatives. Now, it might seem like, why doesn't it go to the negatives? Because it's on the inside. You remember the deal with the inside is you can't trust it? So it might seem like it should be going to over where -9 would be, but it doesn't. You don't trust it. It seems like it should go to -9. It doesn't. It goes to +9. So it's right 9. So that's the tricky part about the inside, is that it's always the opposite of what you would think. You know, counterintuitive. Can you imagine if iPads were that way? When they like want to go to the left, you have to swipe like to the right. If everything was backwards from what it is, they try to make technology very intuitive so that you just sort of like know what it should be, and then you're right. You know, like the pinch in and the zoom out and stuff. They try to really think about what do people expect it to be, and they try to do it that way. Because when you have to go to the opposite world and everything's the opposite of what you would think, it's frustrating. Yes?
I mean, some games have inverted controls.
You're right. And isn't it kind of weird when everything's opposite?
Yeah, sometimes it is used as like a negative effect in a game, like an enemy will give you.
Interesting. Oh, so they like hit you with some kind of a whammy where everything's backwards?
Right, because it's annoying to deal with.
Oh, yeah, it is.
Because you have to get used to opposite movements for a
Yeah.
short time.
Do you guys know that there's something out there that, like, if in the real world, there's this thing called an EMP, electrical magnetic pulse. And if somebody does that to your car, for example, it makes everything like, it's not really backwards. It's just, it'll kind of make everything not work. Well, anyway, there's no real good math tied to that. There's no like thing you can do that makes everything flip in the real world. I mean, if there were, people would definitely use it because it's very confusing. Okay, I'm going to be calling on different people on this one right here. Cole, was that one a vertical or horizontal? Hint, it's on the inside.
Horizontal.
So it's horizontal. It's horizontal on the inside, right? So that's a horizontal flip. How about that 4, Cole? Is it up or down? That's the question. It's up 4. Very good. You could have said U4 would have been the fastest way to say it. All right. Next up, And again, just a reminder, cell phones that come out during class will go up on the front board, so don't be that person. All right, so this is, I'm going to move to this one. Ari, can you tell me whether that's a vertical or horizontal flip? All right, Vo, it's on the outside, vertical on outside. You're right, it's a vertical flip. How about that one right there? Let's go with Tatum. It is horizontal, but there's another nicer way to say it. Horizontal is either right or left. What do you say? That one, should it be moving to right? Correct. You don't have to say horizontal right. You can just say right. Right one. And then last but not least, let's go with Kate Yetka. That 2 at the end. What does that do?
It goes up to.
Correct. All right, moving on to this one. Linus, the inside one? Left 2. The outside part, Linus. Correct. All right. You don't want to have these backwards. Okay? If you start getting your lefts and rights and your ups and downs mixed up, it can be very bad on your test. All right, moving on to this one. It's y equals x to the third, but you got to stick a negative somewhere. Or you got to like put a 9 somewhere. Be ready to be called upon. Noah, that 9, where should I put it? On the outside or the inside? Yep, outside. So down 9. There it is. Did I do it right? Yep. All right, on to the next one. Versioning. They want you to go left 2. So how do I do that with this x here? Do I put it on the inside or do I put it on the outside? It's horizontal on inside. Does that sound like left? I agree. So what do you think I should put in there? Yep. Is it a +2 or a -2? Remember, inside, opposite of what you would think. +2. Very good. And we need the x in there, of course. And then the last thing is the down 6. Now what? You got it. Good job. All right. And let's go with Ian Henschel, this square root here. In with the x, I do something. What? Correct. And then on the outside? Nice job. Now the last one's got a reflection in it. Hudson Pool, save the hardest one for you. Y equals x squared. Where does the negative go? And it says it's reflected over the x-axis. Let me show you something. This is the x-axis. If it's going to go this way, it's going to go over the x-axis. So that red line, is that red line showing you vertical or horizontal? Vertical. So now, final answer. Where do you think we should put the minus? Outside, because it's a vertical on the outside. Okay? And then that down 11 thing. On the outside. Nice job. Okay, moving on. What if you actually had to graph this on your next test? How would you do it? Well, I personally would know that the V shape is y equals x squared. Would you have known? Sorry, absolute value of x. Would you have known that this is based on absolute value of x? It's just been moved a little bit. So if you know it's a V shape, you just got to move it. And it's so easy. Everybody graph the V shape on your iPad. Grab it with the lasso and drag it. Because you're using Notability, they have a little lasso tool. You grab a hold of your V shape and, Jordan, which way should I move my V shape? This tells me right here. Right, how far? And then? Everybody do that. Now, I don't have that tool on my, I'm using something called Explain Everything, and I really wish they had that tool, but they don't. So I have to redraw this thing up 3 and right 2. But that's not that hard. I take the pointy end of the V and I just move it here. And now my V shape is like that. And which way did it go? Right 3 and up 2. I just went the wrong way. Dang it, I'm going to try again. I went up 3. I should not have gone up 3. I should have gone right 3 and up 2. So that's right there. Now a V shape. There. Does the blue one look like it's to the right and up? Then I did it right. Now, that all depends on you knowing it's a V shape. What if you forget?
Excuse the interruption, is Lewis?
Okay, so I'm in the middle of the video. Sorry, there was an announcement there, but so we are supposed to know this is a V shape, but what if you don't? Can you imagine a scenario where a kid in your class could be like, I don't remember what shape it is. I know it goes to the right, and I know it goes up, but I don't know which shape it is. So here's what you do. Everybody right now, XY chart on the side of this picture. Do this. Don't just stare at the screen. You're not impressing me with how much you're paying attention if you're just staring at the screen. You could be staring at the screen thinking about anything. All right. Now, I want you to put in the number 3. What do you mean put it in? Put it into the function. That means you put it in where the x is. How come x? Because it's in the x column. Well, how'd you know to use 3? I could have used anything. I could have stuck in 0. I could have stuck in 10. But generally keep it to small numbers so that they'll graph well. All right, so Nora, I stick a 3 in this function and tell me what happens. And that part is? An absolute value of 0 is still 0 plus 2. 3 plus 2. Oh, my bad. Dang it. Okay, you're right. It's 0 plus 2, which is 2. All right, so 3 comma 2. And let's look. There it is. That's the dot that we just made. It was on the graph. So what's the point if we already have the answer? The point is if you don't know where the graph is because you forgot it was a V shape, you can just get a bunch of dots. We'll get a bunch of dots that are right on this line, and do you know how to play connect the dots? Like if you've got all these dots, of course that's where the answer is. So let's do that on this one, because you might have forgot what this is shaped like. You could, if you knew what the shape was, you could just move it left 2, and down 3. But what if you forgot what the shape was? Then you make an XY chart. And you stick some numbers in. This is the most important thing of the day. Knowing how to make an XY chart. So I'm going to do a bunch of points with you to make sure you've got this. Elijah, pick a number we're going to stick in. Okay, put in 0. I'm going to put it right there. Now talk me through what I get. 0 plus 2 makes, 2 squared makes 4, correct? And then what? 4 minus 3 gives you 1. Look at 0 comma 1 is one of your points. Sinekin, give me a number to stick in.
2.
Okay, we stick a 2 in here, and then you get 2 plus 2 is?
4.
4 squared is? 16 minus 3? 2 comma 13 is one of your points. Jordan, pick a point, or pick a number to stick in.
1.
So we stick a 1 into the equation right here, and then the 1 goes here, and then what's 1 plus 2? 3 squared is? 9 minus 3? Did you have 1 comma 6? Maybe you weren't as fast as Jordan. All right, Nora, pick a number. Okay, where do we want to put it? Okay, and then 3 plus 2 makes? 5 squared makes? 25 minus 3? So 3 was what you stuck in, and what did you get? 322. Now that one was, dang, it was too big. And you just never know until you actually stick it in and see what happens. But now, if I put in even bigger numbers, it's only going to get bigger. So I should pick numbers that are smaller than 3. Ari, tell me a negative number. We'll put in one negative number. Everybody put in -3. Now do it yourself. Put in -3. I'm going to call on one of the online kids for this one. And see if you get the same thing that they get. Putting -3 into the equation. Seeing what you get. Sam Bender, when you put in -3, what's the -3 plus 2 make?
-1.
-1 squared makes?
Is it 1?
It is. And then -3?
-2.
You got it. -3, -2 is one of your points. Let's do one more negative number. I would like to choose -2. Ibrahim, where do I put the -2?
Would you put it?
Okay, feel like you weren't watching the last 4 of them that I did. Pay attention now. This -2 goes right there. What's -2 plus 2?
0.
Yep. What's 0 squared?
0.
What's 0 minus 3?
-3.
That's how we do it. Nice job. Came through at the end. Okay, so there's a bunch of points. Do you get if I graph them? I get to connect the dots with them. And then I'll realize it was a U shape that got shifted left 2 and down 3. But if you had forgotten that it was a U shape, this is what would have told you. You would have just graphed these dots. 2, 13 is like up here somewhere. It doesn't have to be perfect. Wait, that's too imperfect. I'm going to try again. 2, 13 is there-ish. 1, 6 is about there. 322, that's just too big. -3, -2. -2, -3. There. Now, I can't see it perfectly, but here's what I think it looks like. Do you get that's my U shape that got shifted left 2 and down 3? That blue U shape. Now I know it's not perfect. If I need more points to make it perfect. But do you get it gets a little annoying to have to make like 17 points? I have 1, 2, 3, 4, 5 points, 6 points actually. And even with 6 points, one of them went off the graph. You're not perfect, but you'll be good enough. All right. Everybody look at this one. I'm going to draw the original on there. This was what the original looks like. And I'm going to stick in, I'm going to say that 9, 3 would have been on there, so right there. There. There's my original. What happens if you double flip it? This will be interesting to see who knows and who doesn't know. It's going to be flipped both ways. Can you picture in your mind what that looks like? For some of you, that's easy peasy. And for some of you, you're like, I have no idea where it is. So this will be like a little spatial test. It's not like a final, like, you are doomed at spatial things for the rest of your life. But some of you will notice, oh yeah, that's obvious. And some of you will be like, I don't get this at all. Flip it to the left, right, and then flip it up, down. Can you picture where that is? Raise your hand if that seems pretty easy to you. You can flip it both ways and it's like, oh, that's obvious. All right. Well, here, I'll help you if you're having trouble. Here's left, right flip. And then you take that and you flip it up and down. It looks like this black one at the end. How many of you knew it was going to be where the black one is? Okay, cool. See, some of you are going to be naturally good at this, and some of you are going to be like, oh, I have no idea. Then you make an XY chart, and you find some points, because everybody can play connect the dots. So let's just actually verify that this actually goes where we think it does. I think it's going to be where the black one is. So I stick in some numbers, like 0. What happens, do you think, if you put a 0 in right there? What do you think you get? 0. So 0, 0 is probably on the graph, and it is on the graph. Look at that. I put a blue dot right there. And what if I put in 1? Well, look, if I put in 1, there's nothing over here. 1's not supposed to work. So when I put in 1, it doesn't work because I have square root of -1, and that's not legal. So 1 is no solution. There's nothing over here, see? Okay, now if I put in like -1, then I'll have negative of -1, which makes +1. And the square root of 1 is 1, but then I stick a negative on it, and putting -1 in gets me -1 out again. And look at that. It's on the graph again. -1, -1's right there. So what's my point? If you forgot what the function looks like, your XY chart, I call it your best friend in graphing. Okay? You just find some points on the XY chart, connect the dots. I'm going to do one more just to show a point. I've always said you can put in any number you want, but that means you get to pick. Do you think the square root of 3 would work real nice? Nobody knows what the square root of 3 is. In fact, nobody's ever seen it. It's this decimal that goes on forever and never ends. So nobody's seen the square root of 3. It's just a concept. But the square root of 4 is easy. So I'd put in -4. See, since you get to pick, choose wisely. It's a little bit like the Indiana Jones movie where at the end the guy has to pick which cup to drink from. I don't know if you've never seen that. It's a good movie. Anyway, choose wisely. You get to pick. And if you pick numbers for square roots that are like 3 and 7, who knows what the square root of 7 is? Nobody. You can kind of get a decimal idea and get close, but you want to pick nice things. So you get to pick these numbers. I pick 4. Because then I go square root of 4 is 2, and then I make it negative, -2, -4, -2. Once again, it's on my graph. I'm a little off, actually. I can tell my parabola, or my curve, was off just a little bit. Do you see that? I should have been more like this. I was a little too low with my curve. See how that made me make my answer better? Because I connected my dots and realized, oh, crap, I was going a little too low. Okay, there. I hope you feel smarter. How to do problems where they give you transformed graphs. Right, left, up, down, even reflections, flips, and stuff. But what if they just give you a bunch of points? Which got changed here? Did the x's change or did the y's change? Sinekin? Yeah, look, -2 becomes 2. -5 becomes -1. -1 becomes 3. And this is the first one that I like. It's nice numbers. 7 becomes 11. I can do that last one in my head. If 7 becomes 11, what are they doing? Are they adding or subtracting as you go this way? Come on, you guys. If 7 turns into 11, did they add something or subtract something? They added. How much did they add? They added 4. If you look back, all of them were adding 4. This first one just looked weird. -2 plus 4 is equal to 2. What are they doing from here to here? Big shock. They're adding 4. So, what's the point? The y's all went up 4. Oh, so you're saying this went up 4. Yeah. How do you know the y's control up? Because y's go with rise. The y's rise. That'll help you remember it. The y's control up and down. What if I only change the x's? Then I'm going left or right. I'm moving left and right. Okay, your homework is a worksheet. This is the part where I know it's a Friday and some of you have drifted off and I need you back. We're going to start the worksheet together and then you got a bunch of free time. Everybody, find the worksheet, download it, and be ready to tell me the first problem of the worksheet. I'm going to call on a few online people too. Get the worksheet open. So when I call on you to give me the answer, I don't have to wait a long time. There's only one worksheet under today's date, which is the 14th. I'm old, so I'm supposed to be slower than you, but I'm already in. So you should be there. This is the worksheet called U12L1. Unit 12, Lesson 1. RC, read me the first question, number 1. Yep. If I take x squared like this and I change it into this, that went right 3. That's all you'd have to answer for number 1A is right 3. All right, I think you got the idea. Wipe down your desks. Have a great day.